Today we're going to learn about physical and chemical changes, and there's no better way to learn anything than with a demonstration. So what I'm going to do is I'm going to take this hexane, which is the liquid I have in this volumetric flask right here, and I'm going to pour the liquid down this ramp, and you're going to see it ignite. So I get a little nervous when I do this now because it's very flammable. It's a little scary. I have to be quick, so I'm going to pour it. I just want to be very careful when I do it. Okay? I don't know. Maybe I should do a different demo. I don't know. See, I'll get there. It just takes me a minute emotionally and mentally to prepare. Whoa. But I didn't actually pour any liquid. So what happened? Well, a physical change had to take place before any chemical change did in this case. This hexane is a fairly volatile compound, meaning it'll convert itself from a liquid to a gas at room temperature pretty easily. And that's what happened. That was a physical change. The hexane stayed hexane. It had the same molecular formula of C6H14 the whole time. So that was a physical change. No new compounds formed. Other examples of physical changes include all phase changes. Boiling, melting, freezing, condensing, any sort of vaporization. Those are all examples of physical change. In addition to maybe shattering glass or tearing paper or anything like that where no new substances are formed. Then we had a chemical change take place where new compounds were formed. The hexane in the vapor form flowed down the ramp and it reacted with oxygen and the flame. It had the activation energy to start the fire, and then it ignited to produce carbon dioxide and water, two new compounds. Now, there are other types of chemical changes that can occur, some of them being just general corrosion or rusting. Those are chemical changes. And usually you can tell a chemical change is taking place if you see a lot of energy being released, like in this case, or if you see bubbles forming within a solution, or you see a precipitate form. Those are all good indicators that a chemical change has taken place and a new compound is formed. Now, the one cool thing about this demo is that hexane, with a molar mass of 86, is quite a bit more dense than the rest of the air surrounding it. So it was able to kind of stay together and then sink down the ramp into the flame, and then it could ignite. You would never want to try something like this with natural gas, which is less dense and going to diffuse very readily throughout the room. That'll be the last decision you ever make. So let's avoid that. Be safe, not sorry.